Welcome friends. So we are discussing three-phase AC network. Previously we have discussed two different connections, star connection and delta connection. In star connection we have found important relations like line voltage is equal to root 3 times phase voltage and line current equals to phase current. And in case of a delta connection we have found that line voltage is equal to phase voltage and line current becomes root 3 times phase current. Now in this present session we shall discuss few numerical examples on those aspects to demonstrate the relationship between star connections, voltage currents, delta connections, voltage current and so on. So let us have this problem. There are three loads, actually 40 plus J 30 ohm. They are called choke. So the impedance of the choke, there are three chokes connected at each phase. The impedance of the choke is 40 plus J 30 ohm. That means it has resistance value of 40 ohm and reactance value is 30 ohm. That is why we have written 40 plus J 30 ohm. Now Z choke can also be thought of ZL, that means load. That means choke can be considered as a load. So we have three loads connected respectively of at R phase, Y phase, B phase respectively, and they are connected to a three phase 50 Hz 400 volt AC balanced supply. This is the rating of the supply. Now the question comes, this 400 volt, what does it mean? Is it line voltage or is it phase voltage? So this 400 volt always refers as line voltage. The reason being, from the relation of star connection, phase voltage is equal to line voltage by root 3. So if you do that, 415 by root 3, it will be it is approximately equal to 240 volt. Now at our household premises we get this 240 volt AC supply, 240 volts AC supply. So actually in our household premises what we get as 240 volt AC supply, that is a single phase AC supply, right? Single phase AC supply. So this 240 volt is actually phase voltage which is obtained from the line voltage, right? So whatever we are getting at our household premises, we don't require three phase AC supply, we only require one phase AC supply to cater all our loads. So this is 240 volt which is phase voltage. So this 415 volt is the line voltage. This is one. Now if you look the Z choke, now from the impedance triangle, so in x-axis we have 40 ohm, in y-axis we have J 30 ohm, and summation of R plus Jx will be the impedance, that is Z, which is equal to this value. So I am coming to that. Now this angle, from the previous knowledge, this angle is called phi, which is power factor angle. So phi becomes tan inverse of 40 by 30. Sorry, 30 by 40. So what should be evaluated? The first, you need to evaluate phase and line voltage. That is number one, phase and line voltage. The second parameter, you need to evaluate phase and line current. Third parameter, you need to evaluate load power factor. And fourth parameter, you need to evaluate power dissipation. This is the fourth parameter, or four parameters you need to evaluate. Now let us coming to the ZL, which is 40 plus J30. Now if you split them into polar form, so magnitude is root under 40 square plus 30 square. If you solve, it will be 50. And if you solve phi is equal to tan inverse 30 by 40, it will be 36.9 degree. So ZL becomes this value. So with that, what is power factor? So power factor becomes cosine of this angle. So with that, we can straight away evaluate the load power factor. Cos phi is equal to cos 36.9, which is equal to 0.8 lagging. That is our answer for third parameter. So we have evaluated already third parameter, load power factor. Now as already explained, line voltage is 415 volt. Phase voltage becomes 415 by root 3, it is 239.6. So it is almost 240 volt as already explained. So this gives you the answer of number one parameter, or the first parameter, phase voltage and line voltage. So phase voltage is 415 volt and line voltage is 415 volt and phase voltage is line voltage by root 3, which is 239.6 volt. Now what will be the phase current? Now phase current is by using this formula. Phase current is equal to phase voltage divided by ZL, that is the load impedance. What is phase voltage? Phase voltage is 239.6, which is evaluated already, and ZL is this value. So if you evaluate, then it will coming out to be 4.79 at an angle of minus 36.9 degrees. So it is a lagging current. And from that relation of current, that is phase current and line current are equal, for star connection we can say, or we can already write, line current is also 4.79 at an angle of 36.9 degree. Negative angle, of course. So this gives you the answer for third parameter. Sorry, not third, it is second parameter. And one thing is left. So second parameter is evaluated, first parameter is evaluated. So power dissipation is left. Now what is power dissipation? Power dissipation can be evaluated by two different ways. Number one, whatever is the load, that is R and X, which is 40 and J30. So active power, which is power is generally meant by active power. So power is always dissipated in resistance. Reactive power either absorbs or deliver in reactor. That means if it is an inductor, the reactive power should be absorbed by inductor. So active power has no relation with the inductor. So if the current is flowing I phase, so this power becomes I square R. So that means I phase square into R, which is 40. So we have three similar phases. So total power becomes 3 into I square R. So that is exactly written 3 into I phase square into R. So I phase square is evaluated. It is 4.79 whole square into 40. And that becomes 2.753 kilowatt. Also, if we use that formula root 3 times VL IL cos phi, which is derived earlier. So root 3, now line voltage is 415 volt, line current is 4.79 and power factor is 0.8. If you solve this, it will be also the same result, 2.753. So this gives you the fourth parameter. So this is a illustration of a star network. Moving on, it is said that each phase of a delta connected network or delta connected load has a, now this time, a resistance 50 and series capacitance of 50 microfarad. So we have this time R and we have C in series. So R is 50 ohm and this will be given by this formula XC. XC is 1 by omega C. So omega is 2 pi into 50 and C becomes 50 microfarad. So 50 into 10 to the power 6. So if you solve this, it will be 63.7 ohm. Now why this minus 90 degree has written? Because XC is always represented as minus JXC. Minus JXC. So that is why it is represented as minus 90 degree. So it will be minus J 63.7 ohm. So similar fashion we can evaluate the load impedance. So magnitude becomes root under 50 square plus 63.7 square, which is equal to 81 ohm, and angle becomes tan inverse of minus 63.7 by 50, which is minus 51.9 degree. So if you observe your impedance triangle, it is R, which is 50 ohm. This is minus JXC, which is actually 63.7 ohm. And this becomes Z. This becomes Z, and this angle is phi. So phi is nothing but tan inverse minus 63.7 divided by 50. So straight away with the previous problem, same calculation. So load power factor is 0.62. Now this time it will be leading. Cosine of minus 51.9. So now this time power factor becomes 0.62. Now this time is leading because capacitor is there. Now let us see what has to be evaluated. Now same thing, it is the 3-phase 50 Hz 400 volt AC balance supply. Supply is the same. Now evaluate the same thing, the phase and line voltage, number 1, phase and line current, number 2, load power factor and power dissipated, the same 4 parameters. So let us do one by one. So we have line voltage is equal to 415 volt as already mentioned. Now this time for delta connected system, line voltage becomes phase voltage. So phase voltage is also 415 volt. So we evaluated line voltage and phase voltage. This is parameter number 1. Load power factor was the parameter number 3. Now what is phase current? Similar, we get a similar result or similar formula, that is V phase by load impedance. What is V phase? 415 volt and load impedance is this 81 ohm. So if you solve this, you will get phase current is 5.12 ampere with an angle of 51.9 degree. So this time it is a leading current because a capacitance is present. Now in case of a delta network, line current becomes root 3 times phase current. So root 3 times into 5.12, it will become 8.87 ampere. So this becomes the second parameter. And in the same way, the power dissipated can be evaluated at 3 I square R, so which is 3. Now this becomes I phase and R is 50 ohm. So if you solve, it will coming as 3.932 kilowatt. We can observe or we can get similar result with this formula as well, root 3 VL IL cos phi. VL is 415 volt. IL is evaluated as 8.87 and power factor we evaluated as 0.62. So So if you solve this, we will get, I think it is mistake, I think it will be same answer, 3.932. I request you to verify this result. So with this, I am ending this session here. So we have solved two problems on star connected network and delta connected network, and we have seen various mathematical rules. So from the next session, we shall start few more aspects of three-phase AC network. Thank you.